Okay, here's our diode. Here's the positive side. Here's the negative side. Here's our voltage source, conductors, resistor, and a switch. A crowd of electrons forms at the junction. A crowd of holes also form at the junction. Some electrons drift across the junction, and likewise some holes. Now I turn on the switch. Current flows. Ideally, this is how it works. Well, let's make sure it works before we insert it, the diode, into the circuit. How do we do that? Well, I remove the diode from the circuit, like so. And now you take your multimeter and set it to the diode icon. Attach the black lead to the cathode, that's the negative end, and attach the red lead to the anode, that's the positive end. The multimeter should read about 0.7 volts, plus or minus, for a silicon-based diode, probably a little less. And it'll read approximately 0.3 volts if the diode is germanium-based, and again, probably a little less. And that's the voltage drop across such a component. It's the price you pay for using this diode in your circuit. Now, let's reverse our leads. Like so. Oh, this time, negative lead goes to the positive end. Positive lead goes to the negative end. Why? To measure reverse bias voltage. And you get this, OL, out of limits. No current is getting through. And no current can get through. So, what does that mean? Well, forward bias is about 0.3 volts to 0.7 volts, and reverse bias measures OL. That means that your diode is okay. It conducts in one direction, and it doesn't conduct in the other direction. Go ahead, plug it into your circuit.